Good evening, everyone. Today we have gathered here to listen our fourth scientific popular talk. So good number of people are here, offline as well as online. So this I invite our President of Teachers Association, Professor Amitabh Bhattacharya, to introduce our speaker, Professor Partha Chakrabarti.
Professor Partha Chakrabarti, commonly called PPC, doesn't need any introduction, at least in Indian academia. And it is a great privilege or great honor for IIT Kharagpur that this star has not left IIT Kharagpur and dedicated his entire academic career to the service of this IIT Kharagpur and to the service of Indian nation. Professor Partha Chakrabarti completed his BTech in 1985 and PhD in 1988 from the Department of Computer Science and Engineering, Indian Institute of Technology, Kharagpur. He joined the same department as a faculty member in 1988 and is currently a senior professor with a joint appointment in the Center of Excellence in Artificial Intelligence. From July 2013, he was the director of the IIT Kharagpur till July 2019. He was the professor in charge of the state-of-the-art VLSI design laboratory, which he helped set up and has been the dean of sponsored research and industrial consultancy at IIT Kharagpur. He set up the incubation program at IIT Kharagpur and was the head of the Advanced Technology Development Center. He was also the co-director of the Strategic General Motors IIT Kharagpur Collaborative Research Laboratory on Electronics, Controls and Software. He held additional charge as Director IIT Patna and IIIT Kalyani. His areas of interest include artificial intelligence, algorithms, formal methods, CAD for VLSI and embedded systems, and fault tolerance. Professor Chakrabarti has made fundamental scientific contributions in the area of artificial intelligence and automated reasoning and has applied the techniques to solve important synthesis, optimization, and verification problems, especially in VLSI design and embedded systems. He has published 2 research monographs, more than 300 papers in international journals and conferences, and supervised more than 30 PhD students. He has worked closely with industry and government and has successfully completed projects totaling worth more than several hundred crores with MHRD, DST, CISR, NMITLI, METI, DIH, INSA, Volkswagen Foundation, Intel, Synopsys, Google, National Semiconductors, General Motors, ONGC, to name a few. He was the founding architect and overall coordinator of national initiatives like the National Digital Library of India, Global Initiative for Academic Networks or GAN, Spark, Imprint, Pan IIT ONGC initiative, those which are emerging as game changers in India's education and research scenario. Dr. Chakrabarti received the President of India Gold Medal 1985, the INSA Young Scientist Award 1991, Anil K. Bose Award 1995, INSA INAI Young Engineers Award 1997, and the Swarno Jayanti Fellowship 1997-98, Shanti Swarup Bhatnagar Prize 2000, INAI Vishwesvaraya Chair Professorship 2007-9, J.C. Bose Fellowship 2013, and many other awards. He has been elected a Fellow of the Indian National Science Academy, New Delhi, and the Indian Academy of Science, Bangalore, Indian National Academy of Engineering, and the West Bengal Academy of Science and Technology. He received a DSc honoris causa from Kollani University in 2018, and honorary DLit from Techno India University in 2024 for contributions to science and technology. Now, I invite this alumnus character to take the stage and guide us for next 1 hour. Oh.
Thank you so much, Amitabh, and thank you all for coming for this talk. The primary person responsible for hooking me up here today is Amal. He insisted, he's been trying for the last 6 to 9 months, and finally I could not resist. So we are here today, and the topic that I have chosen for today is obviously the topic that I have been doing research on from my PhD. And luckily for me, it is the hottest topic today for all of us. I will try to convey how the evolution of artificial intelligence has happened, how it has evolved from its origins, and how it goes hand in hand with the efforts of the scientific community to pursue research, how it is aiding the process, and obviously, like any foundational scientific tool or technology, it has its side effects, which we all as academicians, scientists, researchers, and lifelong students need to remember. In order to understand the landscape of scientific research, I have broken it down into 6 stages. The first stage is called observation. Tycho Brahe observed planetary motion. So you make observations around the world. And there are a lot of stories about observations like apple falling on your head and things like that. But observation is at the heart of all new discoveries. And from observation comes something we call no knowledge to new knowledge. Discovery of fire is one thing, but that is observation. Electricity, and so on and so forth. So, no knowledge to new knowledge comes from observation. It also comes from mental thinking, like the way people developed quantum mechanics or people developed theory of relativity and things like that. But much of it comes from observation followed by introspective thinking. The next stage is about building a model that is quote unquote human understandable. And this model in its simplest avatar can be a regression model. If I have input x, what is y? But human beings are not satisfied with such regression models or black box models where you give input and get output. They want understanding. They want causality. They want to be able to generalize their reasoning. And human beings are very adept at the art of reasoning rather than at the art of number crunching. Therefore, it is natural for human beings to want methods that explain. And based on that, theories are developed. But in general, for theories to be compact, be written on a textbook, be able to understand, all theories work on simplistic mechanisms. For example, the working of a car, if you look at the theory is one thing, but if you look at a car and see every component of the car working, and everything that happens and how every car is different from every other car, it will not come from a single theory. But why we develop theory? We develop theory because we understand theory. It is easier for us to communicate theory to others, to other human beings. That may not be true for machines. That is why I want to insist on this phenomenon. Then from this knowledge of theory, explainable stuff, generalizable things, things which I have understood now, can I make it to an unknown situation and things like that. From there comes applications. Can I make a car? Can I make an aeroplane? Etc., etc. And finally, it comes to deep, multi-discipline engineered entities that work at economies of scale. Economies of scale, for example, include this fountain pen or a ballpoint pen. If you look at its history, it's histories of centuries of history of writing. But here the science of capillary motion, materials, the ball, friction, everything, there's deep science into a fountain pen. But there is also this mobile phone, and you will not believe that this mobile phone is something that is almost accessible to anybody who earns. And nowadays, you know, there are children who say they won't go to school if the parents don't give you a mobile phone. So, but this mobile phone today, the complexity of the design, if you know that the Intel chips that we have today, just to give you an idea, the wiring of the chip will go to the moon and come back, one chip. That is the complexity. The number of transistors on about 100 such CPUs is equivalent to the number of neurons in the human brain, and almost the same as the number of galaxies in the universe. So with this enormous amount of complexity has been achieved by pursuit of research in science and technology. And in order to do that, people started a reductionist approach, because understanding everything like Leonardo da Vinci is almost impossible to do in a single lifetime. So the community started breaking up disciplines and renaming disciplines: physics, chemistry, biology, and then deeper, chemical physics, biochemical physics, biochemical photophysics, and then so on and so forth, became so specialized that we all have become people who know everything about nothing. We are so big experts that somebody who has studied only the kidney, somebody goes to the heart failure, he will treat the kidney. That was the problem that we had. But that problem came because we went deeper and deeper into every subject. So we understood every subject better, and that has helped us. Along with sciences, economics, social sciences, engineering formed a foundational mechanism for us to build systems. And our main approach in building systems has been automation. Automation is something that human beings have done not only to make their life simple, but anthropologists will tell you things from cooking to riding vehicles, which reduce human effort, have enabled people to spend much more of their brain on thinking and advancing research. Therefore, automation is not only to make your life comfortable, automation has been at the heart of human evolution. The problem is that many of us, until we reach the age of 60s, we are so much striving for success in our own disciplines, forget these connections that we have to do. Then with this reductionist approach where every discipline is super specialized, came the first integrator. The original integrator was mathematics. Mathematics was the original integrator of disciplines. But mathematics was difficult to do for all disciplines. Mathematics was difficult to do for an architect, for an artist, for a poet, for somebody else in biology and things like that. We always knew that it is a PCM or a biology thing, and you don't study mathematics when you do biology and become a doctor. But the one dimension that almost changed everything and enabled us to look at every discipline of science in a deeper manner, to understand very complex mechanisms beyond equations, was computing. The digital computer, which enabled a human being to write any method that they thought they could write, implement it, visualize it, and see it, started becoming the first integrator of all disciplines. And as I jokingly say, that computing became the spouse of every discipline. Computational physics, computational chemistry, computational biology, computational social science, computational linguistics. So it became, the girlfriend, boyfriend of every discipline. And therefore, it started forming the first integrator, because you could now integrate a biological system with a physical system using a computational model. You could look at how proteins are changing and how they are affecting the flow in your blood cells through a computational model. Therefore, this opened a completely new paradigm and started bringing people together. The other most important development that helped was not just the transformation of electricity, electrical engineering to electronics to this advanced miniaturization. As I said, that we now have more than 2 billion transistors on a single chip, on your pocket. So this combination enabled us to really advance science, and most importantly, integrate everything, and even more importantly, automate everything. Now this process of automation, which started with computing, also had a Krishna Balaram brother called artificial intelligence. The person who coined the foundational model of computing, wrote the first paper on artificial intelligence, is Alan M. Turing, around the same time. And his paper was titled, "Can Machines Think?" So as I said, computing changed the names of every science. Now you call it decision science, you call it so many other names. So we moved from computation to artificial intelligence, and for us, we are such egoistic people that for us, the ultimate of everything is ourselves. We do not believe that any animal can see more than us unless some biologist or scientist or cognitive scientist brings data to you, then you'll say, okay, ठीक है. They don't believe that anything can do better than us. But as of now, probably we are the most quote unquote intelligent general purpose entity on the planet. So the objective that was defined was, can we build automation to a scale that will replicate the human being? And today we are at the cusp of a fear that we have reached a point where the thing that we have built is arguably, probably better than us in terms of many aspects which we hold dear to ourselves. Whether it is creativity, whether it is invention, whether it is discovery, and so on and so forth. And we have reached a point where psychologically the human race is unable to cope with the fact that we have created an entity which is more intelligent than us, or potentially more intelligent than us. And therefore all the fear. But if you open up the whole mechanism of how things work, then, as you always know, that a black box which does something is more fearful than when you open it up and you know its mechanism, then obviously much of the fear will go away. The other fear that we have is that we are now using electronics to instrument ourselves. You must have seen the latest Instagram post where some student hacked the Google Lens, put it on his eye and was playing chess. So you can imagine what will happen to our JEE exam. So the first attempt at trying to do automation, and the difference between automation and computing is the following. In computing, we human beings tend to write out the method of computation. That means we not only describe a problem to be solved, we also enunciate the method by which the problem can be solved. So the first steps at automation was in the attempt of automating the solving procedure. So it was called automated problem solving. So here we know this is a Google map, this is a chess playing, this is robot assembly, this is an integration problem that we solve by hand, this is our own timetable system. I don't know if Sudhir was the architect of this timetable at some point in time. This is the VLSI chip. The heart of automation, of automated problem solving, is that I will describe all these problems on a single template. I will not describe each problem differently. I will define each of these problems on a single template, and I want to have a meta algorithm which will solve any of these problems. This is at the heart of automated problem solving. But still, we used two artifacts. One artifact that we used to actually solve problems using computation is the idea of a programming language. Languages are natural to human beings. In fact, music is even more natural to human beings. So we use these computer programming languages that we developed, and it is a language. Why did we develop it this way? Because it is a language which we can translate to execute, but it is a language that human beings can understand. If I just give you 0, 1, 0, 1, 0, 1, 0, 1, you won't understand anything. So we made these high level languages, but these are restricted. These are not human-like languages. These are not languages like problem statements in our geometry book. Prove that this and this and this. If that happened and that happened, show this happens. So this was the origin of AI, where we started trying to define mechanisms by which we could have a meta algorithm that solves every problem, provided we describe it accurately. This is where comes the catch. But human beings solve problems, even they are described vaguely. So based on this is the star of AI that I call it today, but it will change over time. Here are the three paradigms or pillars on which this automated problem solving, which has evolved into what we call artificial intelligence, is developed. The red colored parts form the base triangle. The first, as I said, can I represent any problem description in a generic way? Any problem. The second is, given any generic problem description and a query to solve that problem, do I have a method, an algorithm, or anything else that can solve any problem? That means I have a generic representation to the problem, and I have a generic method which solves any problem. The third part was what came out over a period of time, basically from human understanding of how human beings do things. As I said, the best test case of intelligence for human beings is how do we do it? Was learning. Learning allows you to solve a problem better the next time. So what does it do? It does two things. It helps improve your reasoning method. It also helps improve your representation. And then there is the three-way effect. Improved representation helps solving and learning. Improved solving helps representation and learning. Improved learning helps representation and solving. This starts the churning of AI. Then AI in its current avatar, and AI is a very beautiful animal. It goes to a subject, decides that it will own this subject now. It will become, that subject will become AI. And therefore, it renames the subject. So it went to the all of symbolic reasoning of algorithmists and logicians, which is crisp reasoning. All our algorithms are crisp. If you give a sorting, you get a sorting result. If you give a reasoning problem, you give a reasoning result. You get for any input, the output is fixed, which is not necessarily always true for a car moving. It may go a little bit this way, a little bit that way. So it changed all algorithmic AI and called it algorithms and called it symbolic AI. So it took over annexation of algorithms. But then it found that a large amount of learning needs to be done from data which is produced out of various attempts at solving problems. And this data and results tend to be incomplete, tend to be error prone, and have many other things. So, but this was already being done by somebody in that field in a field for a long number of times, and that was called the field of statistics. So next came the step called annexation of statistics. So they put algorithms plus statistics and put in a little bit of domain knowledge and called it data science. So AI people changed another discipline, usurped another discipline, gave it a new name and said that is me. But even while solving statistical problems, there were certain problems which could not be solved automatically by these methods. What were they? If I give you pictures of people sitting here, I recognize Amitabh, I recognize Shudev, I recognize William, I recognize Pallab, and I recognize them instantly. I don't recognize them by if then else loop, right? You don't recognize anybody by running an if then else loop. Secondly, If I ask you to tell me why did you say it is Amitabh, you can write 200 pages, but that will not be sufficient. So this sort of instant cognition, which is at the heart of research, most of us have thought and suddenly we got an idea. We don't know how we got that idea. We call it in many ways, but we don't have a scientific basis of how we got that idea. And that concept of instant recognition does not happen algorithmically. That concept of instant recognition does not happen statistically. So again we went back to understand how we do it. And from there, computer scientists tried to study, and then they came out with this simple model where they came out with a cartoonish model of a brain's neuronal structure. And they called it artificial neural networks. This artificial neural network is nothing but a circuit. But all of us know circuits are with AND gate, OR gate, NOT gate and logic gate. And these circuits were replaced by simple nonlinear elements. By including simple nonlinear elements in these circuits, people were able to prove that they can realize any function, they can realize memory, they can realize past history, and so on and so forth. And that is the reason why two of the people here got the 2024 Nobel Prize. One of those networks is called the Hopfield networks. So now what happened was representation became a combination of symbolic, statistical and connectionist or neural. So immediately AI people changed the name, they called it connectionist model and said that is ours. Neuroscientists are running after them now. So now representation could be symbolic, statistical, neural, reasoning could be symbolic, statistical, neural or mixed, and learning could be symbolic, statistical, neural or mixed. This combination makes modern AI today. What has it achieved? It has now taken a human being away from the task of solving the problem, it generates the solution. And from generating solution after solution, it now starts creating models, creating possible futuristic models of its own. The one person at the corner who has still not been touched and will make this a four-sided on all sides is quantum. Once quantum becomes really implementable, it will change the paradigm of AI even more, and I am waiting to see what AI people name quantum and take it up as their own. But let us remember one thing very clearly. In order, and pardon me, many of people here are experts and I can see them. Therefore, many statements that I will be making are quote unquote loose. Alright. They are loose for two reasons. Because one, I may not know the exact type statement. So whenever we do not know everything accurately, we say in Bangla, opor diye bole dilam. The other is, it is not possible for me to give a popular lecture by start showing all the mathematics and everything else. So let us look at the problem at hand. All of us know the problem of regression. That means we have x-axis, we have data, we have the x-axis and we have fx. And we have lot of data, but we don't have all the data. This is our pursuit of science. We have some information, we don't have all the information, and by looking at the x-axis, we have several points of fx or y-axis. And therefore, we have two problems at hand. One problem is given any unknown point in the x-axis, we want to predict what is the y-axis. And the other is, given any unknown point in the y-axis, we want to predict the x-axis. Typically, the x-axis may have multiple dimensions and the y-axis has 1 or 2 dimensions, one maybe. But today's AI, the x-axis can be numbers, pictures, words, sentences, facial expressions, brain data, etc., etc. So look at it, and these, normally our x-axis has got linearity, but images, text, these don't have linearity. So they are in the level of a billion dimensions, and y-axis in the level of a million dimensions. So I am giving a billion points here and trying to predict a million points here. So 1 point corresponds to million dimensions in the y-axis. So what is the fundamental rule of trying to do this sort of interpolation? That there will be errors. The errors depend on many things. The errors depend on whether the data was accurate, whether the method has bias or is accurate, so there will be errors. And therefore, all of AI reasoning will have errors, because it is a combination of crisp, statistical and supra-statistical or connectionist reasoning. And therefore, AI methods are known to have this property. It is probably approximately correct. Which means that if I tell you a point is 0.25, then it will be within some epsilon boundary of the actual point. So if I tell you that I want it to be 90% within the actual boundary, then I will say that if I give you 90% within the actual boundary, then my confidence is 85%. But if I have to give you 60% within the original boundary, my confidence is 95%. So there is a confidence, there is an error. So that is why, remember, we have to remember that at every point, because this is a very, very glorified interpolation problem, where even causality is an interpolation, even explanation is an interpolation, everything is an interpolation. Therefore, this is a loose term. Therefore, it will have errors. Now, normally when I have x dimension and I predict y, x is many and y is 1 or 2, then I call it interpolation. But if I give you y and ask you produce many x's, then this dimension is much bigger than this. Therefore, the error in this reverse interpolation will be high. And now to give you certain terms, the x to y in AI is called predictive AI, and the y to x is called generative AI. That's all there is to these terms, which we use to make sure that none of you enter our fields and we lose our jobs. So AI is a large discipline with many, many fields, but there are certain things which are at the heart of AI. Like all of research which embeds the word search, the foundation of all AI is search. It is searching for a solution. Now the other foundation of AI is knowledge. And the cardinal rule of any AI method is the more knowledge you have, the less search that you are expected to do. The less knowledge you have, the more search that you are expected to do. If you are not aware of this campus and you are asked to go and find some room in Nalanda, then the amount of roaming around that you will do to find that problem, which is like our research, which we roam around. And then you come back, supervisor, sir, what to do? Then supervisor gives you little knowledge, if he or she knows. But the cardinal principle of AI is knowledge versus search. More knowledge makes you do less search. The second principle of AI is deduction. Deduction is a different way of solving problems where you describe the problem but don't solve it. For example, this says wherever Mary goes to school, so does the lamb. Mary goes to school, so the lamb goes to school. I didn't prove it. I just made some statements, but this statement is true. So logic is a parallel to computing. Logic has the same power of computing. Anything that can be computed by a procedural computing program can be written in first order logic. This is the fundamental and cardinal rule. But all of this, as I said, is crisp. If it happens that wherever Mary goes, lamb goes to that place 90% of the time, then all my reasoning changes. So incomplete information, inaccurate information, to model all that, we have given rise to this mathematical tool called probability. And probability gives you certain directions, as we said, it is probably correct, with so much confidence. But we want to express all our problems in natural language. We want to talk and converse with people and understand and solve in natural language. The languages that we use today are programming language or formal languages. Natural language is obviously much more complicated because it contains ambiguity. For many of you, especially when you are young, natural language has ambiguity. It says, suppose I say I want to go to the bank near the bank. The second bank could be Bank of the River, and so on and so forth. And then it is even more complicated. You are sitting with your girlfriend and you say, Tale jai, can I go? And your girlfriend says no. It means yes. If it says yes, it means no. So language is very complicated. It is not amenable to general purpose reasoning that we are used to. When many of us teach in class, we have people from all over the country. You ask, have you understood? Somebody says this. Now this can mean no for North Indian Bengalis, yes for South Indians. So you have to now guess, ye South Indian hai ki nahi. So understanding natural language, describing problems in natural language, and having the ability to solve this automatically is at the heart of AI. And all of us know that today with ChatGPT, what will be the title of my PhD, etc., etc. Please write the abstract on this. And the best one which we have is as follows. One of our MTech or BTech students was not meeting his supervisor. And the supervisor is a strict guy. All computer science faculty are not strict, but this fellow is very strict, very good, very strict. So he says, at the end of as it happens, Viva 3 days left, or 7 days next Viva is there. Sir, I want to meet you. I kabhi nahi aaya iska pehle actually. So he says, why do you want to meet me? I don't want to meet you. Sir, please give me, etc., etc. So he says, no, you have to tell me exactly why you will meet me. So kahan jayega? He took all the email conversations Office supervisor gave it to ChatGPT and said, "हमको एक लिख दो चिट्ठी." So a letter was written by AI and he got the appointment. So we have reached this level of competency today by this simple artifact. So then comes learning, machine learning, and machine learning is of three kinds. The first is like we teach in class. We teach a few things and ask questions around it. Basic interpolation problem. Generalized interpolation problem. You give questions, answers, you give some methods. The other is more research oriented. You give certain other things and ask them. So you give pictures of cats and flowers, and you can immediately make out that these are two different categories. So similarly, can you really do some sort of pattern classification without being told what it is? So that is the method of unsupervised learning. The third method of learning we all learned when we were children. Plug में हाथ दिया, घचांग शॉक खाया और कभी नहीं दिया. And then you know all these children, how they can patao their parents, grandparents and all that. That they have learned by trial and error without anybody telling them what to do. And that is called reinforcement learning. You take an action, then you analyze whether this is a reward or a penalty, and then you decide whether to do that action next time or not. I still remember that human beings do this reinforcement learning in different ways. When my daughter was, when my sister was, when we were little children, my sister would, my father would scold my, parents, father can hardly scold a daughter. Most of us who have daughters, it's impossible, So my sister would go, my father is scolding her, she would go and watch. What is she watching? She is watching whether the eyes are scolding or not. If you watch very carefully, looking at the eyes you can make out whether this person is actually angry or not. So reinforcement learning, unsupervised learning and supervised learning, these have mathematics, statistics and algorithms, but this is what they are. But they are founded on nothing but generalized algorithms plus statistics, which is more sophisticated versions of doing generalized interpolation in a better way. Then came these neural networks. These are called feed-forward networks, which don't have, each of this is a simple nonlinear circuit, and this one is proven to be able to realize any mathematical function to any level of accuracy. This is the famous all connected networks or the Hopfield networks, for which Hopfield among other things got the Nobel Prize, which can realize memory, associative memory. You remember? I will give you half the picture of Gandhiji and you will know that this is Gandhiji or Tagore or somebody else, etc., etc. Then there is this winner-take-all network, recurrent networks. Each of them can realize memory, can remember history and things like that. But all of them, with a pinch of salt, all of them will have errors. All of them will have errors. So whenever you use AI, make sure you understand that it can have errors, what kind of errors, and where do the errors originate from. Because if you are not alert about that, then you will get wrong results and get into trouble. Till then, machine learning was interesting. Human beings would look at data, extract features like, okay, there are curves, there is line, there is, In the heart, you will say, you'll get an X-ray picture, doctor will label the patches, etc., etc., and you will use this data for machine learning. Deep learning obviated that as well. I'm not going into architecture, but what deep learning did was deep learning says, you just give me data. I will figure out the features. And the more data you give, the more accurate it is. And among the deep learning architectures, visual reasoning or visual learning, the Turing Award went to some people who did this starting with the US postal system and developed the now very famous convolution neural networks, which many of you are aware of and many of you have used. This enables you to be able to understand aspects and features that are often not human understandable. It is able to detect cracks which humans are not able to do. It is able to detect fine aspects in X-rays or fundus eye images which human experts are not able to do. The second aspect was reasoning over time, time series. Time series from stock exchange to hearing sound, to hearing words, sentences, and everything else. So the heart of this prediction problem in time series is your autocomplete. You write something and it tries to autocomplete, which is called the next word predictor or the next label predictor or the next entity predictor. And this has many other architectures, of which the LSTM and various others, and there are things called transformers, etc., which I am not going to. So what has AI ML able to do? It takes complex information, collates it together, tries to find patterns, and tries to predict things in a way which human beings would not be able to do ab initio. But taking the help of AI, human beings are able to advance things in a much better way. So what are the AI's conquests? Many of my friends will remember that many of my slides are repeated for the last 20 years, which is natural. So this one, you know who is this guy? This is the great Kasparov, first time the human being lost to a computer. This is about interacting with a machine, a robo-citizen. Today you may be knowing that when a Boeing aircraft flies, almost every data is transmitted back on the ground. And if there is a fault, either they try to repair it in place, or by the time they come back, the replacement is often always available at the aircraft level. This is all done by this fantastic method of AR, VR and AI. Let us imagine this rover on Mars. It takes 4 minutes for 8 or 12 minutes, 4 minutes I think for data to go to Mars. With so much of little of memory, this entity was roaming around. But now we come to the most intriguing character today. The most intriguing character, people said, is that everybody is learning flowers, biology, chemistry, physics using AI. Can we learn everything? That means, can we put all knowledge together into a single network, into a single AI model? And that is called the foundation model. And this foundation model is built on very sophisticated techniques, but at the heart of these sophisticated techniques lies this interpolation and reverse interpolation problem. The interpolation problem is called predictive AI, where if I give you a picture, you will try to predict this guy is 30 years old, this is a male person, this is walking with a stick, etc. etc. What does how does this do? What it does is it takes all this data and these labels and creates this orange colored stuff called the model. As I said, the representation. The other is the reverse interpolation. I tell you that given y, give me x. Give me a man walking, a video of a man walking, 60-year-old walking with an orange shirt, limping on the left leg a little. It will give you. So it is the reverse interpolation. So that is what is called generative AI. So this generative AI, earlier you were giving it poetry and you are asked to find out the meter, the rhyme and everything else, the sense, what is it talking about, who has written it, etc. Now it is the reverse. Give me a poetry written by Swami Vivekananda on flowers or something like that. So it is the reverse interpolation. And that is what is called generative AI. And this is an encoder which forms the model and a decoder which generates the result. And this is what is there as a cartoon of the large language model that you hear of. In order to build this large language model, the ambitious task was to take everything in the world and put it into this single model. That is what we see as ChatGPT or Gemini or whatever we see. All they have done is they have labeled things and got it into this single model. And then by this single model, if you want to restrict it and say that no, I am only interested in chemistry, in this sort of reactions in chemistry. So all we do is we call it fine tuning. We tune it on a little bit of data of this model. So we have this large model and we fine tune it on a little bit of data of this model. That became more and more advanced to what is called prompting. Prompting says, for example, in prompting you may ask the question that how does a ball spin? So it will give you many answers. But you may give a context. You can say, I am talking about cricket, and then say, how does a ball spin? So, as soon as you give a context, like all of us, you go to a doctor and you give a context, my stomach is paining. So, immediately, for all the symptoms are related to something which is in that context. So, you give a context and then a query. And no longer you need to give data as such. The data is also a query, a sentence is also a query, because every, as I said, whether it's a sentence or a picture or a combination of anything, is at point in that 1 billion by 1 million dimension space. So, what was the problem with this? The problem with this was that now we come to another very fundamental concept. The fundamental concept is that AI is not human. AI does not see what a human being sees. AI does not think like a human being. We are imagining that we are making AI think like a human being. At the far end, it is just a computational model. So, it will start giving you things that human beings consider atrocious. So it will start spewing, galagali. It will say, it will use words that it is not supposed to use for you. So it requires what is called human guiding, some moisturizer by human being. So this is what happened by this technique called RLHF. It was reinforcement learning with human feedback. So that you do not get vicious images, you do not get all these very nasty things at the end of your search, though the result could have been part of it. comes because it has been trained that way. And how has it been trained that way? Millions and millions of people were paid a pittance to do this training in the heartlands of Africa. And you can imagine they were shown pornographic images and to label it porn. And these people have had psychological problems having done that. So all our efforts of achieving many things, like you have seen that in many cases, many of our scientific advancements of surgery and human anatomy, where slaves were cut and people found out all these details. So it has come at various big cost. But at this cost, we have now come into this modern avatar of, as you see, ChatGPT, which is the foundational model with human labeling. And every time you are interacting with ChatGPT and some of us are paying for it, can you tell me what we are doing? We are training it. Every time you are accessing it, you are actually training it better and better. So you are paying to make it better. So what are the glimpses? I'll just go through. So one program, one AI took all equations of, and they renamed the elements. Some other names they give, some numbered names. And then they said, now can you put all these elements, looking at the reactions that they have, can you put all these elements in a tabular form so that the ones which are related are next to each other, closer to each other? And can you guess what was produced? Periodic table. Ladies and gentlemen, the periodic table, almost the periodic table was produced. And the periodic table, as we know, is probably the most foundational compact table that has been known to advanced science. What is the other equivalent of the periodic table, which, like the periodic table, which could have been found algorithmically by hours and hours of optimization? There is one more table like that, which has been used to generate newer things in a very similar way, and that is the Sanskrit table. The Sanskrit table and the periodic table have uncanny similarities. Then, how do you predict organic synthesis? How do you predict the result? So we are getting 97% accuracy in minimum time. How do you predict materials, new materials? We are able to predict optimizations of models. We are able to do this. All of us have this CRF and all our labs. We are not using all our data. If we combine all our data, we will be able to do much better analysis using AI ML, which we are not doing. So this is my student, our BTech PhD, who has developed this blood digital microscopy at 1/10 the cost of a foreign made machine. During COVID times, we worked with some of our colleagues in aerospace, Arnab and others, to be able to model aerodynamic parameters with very, very high accuracy. This is my student who is sitting there. You take complex software code and you want to summarize it. How do you summarize software code? And if you see software bugs and errors, those who are aware, there's this huge complicated stuff, and how do you, so summarization. And the heart of summarization came in legal analytics. How many of you have read a legal document? Whereas and whereas and whereas and whereas and whereas and whereas. That is a small one. So, how do you predict legal judgments? How do you make a new legal judgment? Some of our colleagues are working here. How do you summarize it? How do you convert it into point-wise form? So the whole of legal domain, how do you write a response? Then comes this electronics embedded with AI. And after a few years, if will be having, maybe he'll be logging on and say, not even logging on, speaking, "Hi doc," the doc is some robot or whatever, we don't know. Or the robot has given salary to a human being to respond, we don't know. So he says, "My kidney is not working properly." So he says, "Give me 5 minutes." After 5 minutes, he says, "Go, is it working?" He says, "हाँ, आज तो ठीक काम कर रहा है अभी." "What did you do?" "Arey, your kidney was artificially printed. I downloaded a patch. There was a software bug. I corrected it." So we are going to get everything replaced. Some people are getting knee replaced. We'll have kidney replaced. We'll have everything replaced. Don't worry. You won't even know who you are. But today we have these integrated agriculture sensors where from the field, from the sensing, and there are deep architectures, AI architectures, which are able to monitor. And many of these companies don't sell tractors anymore. They give you the tractor for free. Only you have to give them the data. They give you the tractor for free. Only you have to give them the data. This is Suman's work during COVID, where he and his team, I think Arindam and others were also there, where they trained how to detect things using lab experiments. And then at the blood sample at the site, just by looking at the color that is changing, they are able to do this prediction of the disease, which we have started doing. I'm collaborating with somebody where looking at structure and function, and then having got data on structure and function, looking at structure, predicting function. So people use it in welding, in reality, in human-robot interaction, which is a very interesting thing, because human-robot interaction is something we need to do more and more. The first AI-generated textbook was on lithium-ion batteries, and my battery experts will be surprised to know that it was the most authentic textbook written completely by AI. In 2019 or 21, people took an AI to read all papers related to thermoelectric materials, and the papers were read up to the year 2009. And AI does not know anything about thermoelectric materials, it just reads text. It reads only text. And it was asked to predict the next level, next few thermoelectric materials. So it predicted 5. And the top of the best of them, which was predicted by reading papers up to 2009 and spending about 20-30 hours of compute, was found by human beings in 2012. So what I'm trying to tell you, and coming more to the topic, is that it accelerates your research to a level that is unheard of. So today, ChatGPT predicts proteins structure. And what has happened? Previously, 5 years, 1 PhD, 1 protein structure. These guys who got the Nobel Prize, they predicted 200 million, which means 1 billion years of research. Please try to understand the impact of AI. And other than Hopfield and Hinton, and we are very happy that I still remember Vinod, Professor Ghosh and I, there was Rumelhart and Hinton, and when they were developing these boards in the early 90s, these neural network boards, accelerator boards, when we used to do research at that time, we used to communicate with them and they used to send us those boards and stuff like that. And the people who got the Nobel Prize in chemistry, so computer scientists, but this is not the first time computer scientists got Nobel Prize. The only computer scientists who have got Nobel Prize are AI people. But the first guy was Herbert Simon. In 1978, he got Nobel Prize for Economics. He was one of the founders of this concept of automated problem solving. So now, people have become more ambitious. People are now writing AI to create experiments. They're writing simulators to run those experiments, returning it to AI to generate the next experiments. And this cycle is going on automatically to generate next level of materials. People are even more ambitious. People are now saying, and for PhD students in particular, except my students who are here, is that it is saying, what is the topic of next research? Which topic I should do research? Which topic I should do research so that I can publish in this journal? It will do everything for you. So this is the paper we just got out, where we are using these large language models in generating novel ideas. So anybody here who is having problem with supervisor, मेरा पास आ जाओ, novel ideas मिल जाएगा. Education, it is transforming everything about education, whether it is assessment, whether it is teaching, etc., etc. Amitabh is looking at his watch. And now it is infiltrating humans. Recent results show that looking at the eye tracking, you can make out whether this person will be able to solve the problem or not. All of us who teach, we know that when we look at the class, whosoever is understanding, not understanding, you can make out from their faces. So, behaviometrics, brain-computer interfaces. Some of my students are now able to predict the progression of Alzheimer's disease. And finally, looking at brain images, people are able to find out what they are thinking in terms of sentences. So this is the level at which this little toddler has achieved. But remember that if you give it a very deep, specialized scientific problem and ask it to give you an answer, it may be okay for a layman. But to a person who is an expert in that field will find many, many problems. Many, many errors, factual errors, logical errors, connecting errors. It's not as good yet. And that is because of that probably approximately correct and the fact that it doesn't have enough knowledge of that subject. So pitfalls, AI is not a human being. Human beings see these differently than an AI. A human being will see this one, will see two kinds of images coming up and down or coming up and down. That is because of the structure of our eyes. So people are trying to develop a model like the human being. Then there is humor. Grandfather says, when I was your age, I used to go to the market with 2 rupees and bring home soap, rice, milk, bread, ghee, face powder, etc. Grandson says, nowadays it is difficult, Dadu. There are CCTV cameras everywhere. Why did we laugh? The question is, why did we laugh? There is no logic to laugh. Humor, emotion, these are being slightly infiltrated upon. But the dimensions of humor and other things, sarcasm is being touched upon, but humor, look at this one. He says 10x minus 5 equal to 25, then x equal to 3. So this guy says, Professor, you said yesterday x was 5. Humor is a very funny thing. we still consider it to be a human trait which is different from logical reasoning. Is this beyond AI? Will AI produce another Tagore, another Ali Akbar Khan? Beware. There is music which is replicating Bach. There is painting which is replicating Rembrandt in terms of even the painting, how it looks like. If you touch it, it will look that way. And you know that everything that you do, Mahan Google is watching you. I hope you are aware that your phone, your smartphone listens to everything that you say. The biggest Wi-Fi in the world is not your mobile phone. The biggest Wi-Fi in the world for us male members is WIFEEYE. These are illusions for human beings. These look tera mera, but they are straight lines. To computer or AI, it is not an illusion, because they will measure everything, na? So the reverse is also true. AI in its billion by trillion dimension space, billion by million dimension space, has illusions which human beings don't have. Which means that if I change the picture of a pig by changing 20-30 pixels or maybe 1.005% pixels, AI will predict it to be airliner or anything I want it to be predicted. But to the human being, it still looks like a pig. So this leads to optical illusions for AI. That means AI is going to make drastic mistakes with very small changes in its data. So there is a need to make AI explainable, because human beings understand explainability. It is not for anything else. Let us remember, when two doctors talk to each other, have you heard two doctors talk to each other about a patient? See, suppose you have brought a patient, something has happened and two doctors are talking, you will not understand a sentence. You will not understand a word. But when they tell you the same thing, you think you have understood everything. Similarly, when AI talks to AI, it's a different ballgame. So we want to make AI tell us why it did it. So we are trying to integrate causality, interpretability and things like that. So AI has spread into everything. The biggest dimension that AI has spread into, and the biggest challenge, is personhood. AI is attaining the power of being a person, designated as a person. So once it is a person, it will own land, property, etc., etc. If AI makes a mistake, who is liable? You can't even catch who has written the program. It is a mutated program. So should we worry about today's AI? Bias, weapons, liability, jobs, hate, fake, we are seeing it all over. Therefore, this error of AI is something that we scientists and researchers should be completely careful about. If we are taken for a ride like everybody else, we will be in trouble. The world will be in trouble. And then whose problems are we solving? We are using AI to ensure that this person buys the more expensive shirt from a more expensive company so that somebody abroad will get the money. So we are using this to make life comfortable for those who are already comfortable. But the same technology can be used to make life better for those 90% of the people who are below, who have only 10% of the wealth of the world. So as we move to a new level of society, How many of you have seen this in Kharagpur railway station? When you get up the stairs on the right side, there is Gandhiji's talisman. I think you should go and watch it. So human-centric AI, so the research that we should carry out, if we try to improve large language models, give more prompts, nothing will happen. We have the opportunity to solve newer kinds of problems, newer areas of research. And those areas of research in AI should be about trustworthiness, creativity, safety, empowerment, enablement, and so on and so forth. These give rise to different problems. So as I have tried to make out, AI is probably the biggest generalized integrator of all knowledge. The knowledge that we dissected to make things better and understand at microscopic level, it is able to integrate. It enables you to think about newer things, but it also touches upon some of the most valuable, some of the things that you hold very close to your heart. Your ability to write poetry, draw diagrams, create, it is going to do things better than you. So how are we going to ride this tiger? And how are we going to, as an institution, today we have so much data coming out of all our machines, all our electronics, our test machines, CRF, this, that, we don't use it, it's just all junk. So if we put in an effort together, I think we should be able to do much better and come out with newer things that will probably make a better name for ourselves. I hope I didn't bore you too much. I have finished, by the way.
Thank you, sir. So some questions.
I told you, in my report, this public trial. So.
Excellent talk, no doubt about it. This is the two questions, one is on the lighter side, another one is how do you see the future of AI next, and let's say after 20 years? That's the one. On to the, because there's a lot of things are being predicted, and because to predict all those things we need a equal and more than this hardware. And once we have a lot of hardware requirement, it means we are again, people say, okay, this anything is coming to the climate change, though we are going to solve the climate change problem using AI. It may happen. So how do you see the future of AI next 20 years? And second, on lighter note, is it possible to train the politicians by AI?
So the first question is that, everything is going to be instrumented, and therefore all the interfaces that we see now are going to completely change. All the interactions that we do now are going to completely change. Many of us, like me and some of my colleagues who have been in that era from where we wrote code in punch cards to what we see today, but people are going to be born native AI. So they are going to be born native AI, they are going to be able to communicate in ways which are completely different. So firstly, there will be a massive instrumentation miniaturization. AI is going to start using less and less power. As I did not mention, while compute, bandwidth and memory have been conquered, power has not been conquered. And therefore I feel that there will be some change. And in 20 years, quantum will show its face. So I think there will be a dramatic transformation. I will die, so it's all right. The other question I will skip. See, sometimes you should not try to evaluate the gods. Offline I will tell you.
Hello, sir. Few years back, it was this AI, like we see today, was considered unethical to develop something like that. now we see it being accepted by all of us, and so no one has any questions. And also there is a lot of money involved in this. So what do you think? I mean, is there anything unethical at all in this world?
So the cardinal rule is that the weak cannot define unethical. Have you ever found the weak defining anything as unethical? So in order to really define AI as unethical, you have to become the master of AI. If you do not become the master of AI, you will not be able to transform AI. You cannot change AI by not becoming a champion master of AI. Today all the masters of AI are teaching you what is ethical, what is unethical. But you think that is not true. But you have nothing to do unless you become equally competent. So it is very important that this very dangerous tiger has to be ridden. So as a nation, unless we use our manpower to really become masters of this subject, such that the destiny of the world depends on the people of this country, and if we are able to define the ethics, that is how ethics will be defined.
Yeah. Thank you, sir, for that mesmerizing talk. I didn't even realize how 1.5 hours went past. My question is about the ability of AI towards creativity and innovation. You did mention in one of your slides that AI can generate music like Bach today, but can it create another Bach or Beethoven? That's my question, and where is that going to?
Potentially, yes, but the infinite dimensions that are open to creativity. For example, forget about music. If we ask the question, will AI be able to produce a theory like quantum mechanics? Will AI be able to produce a theory like relativity? The answer today, we don't know, because we are looking at it as a problem which is exploring the state of possibilities. But these come out of states of potential. They are not in the range of known possibilities. So things which come out of the state of potential, I don't think we have touched upon it yet in our representation.
Hello. Thank you, sir, for nice talk. Sir, my question is, you have mentioned AI has reached to mind. What about consciousness? Consciousness. Can you make AI Brahma or Kali?
See, let me tell you the fundamental problem that we have in our model. All of our science, these are certain things that we must understand. All of our science is founded on something which we call set theory. And we know infinite sets, we know the power set of infinite sets, we know Cantor's theorem, so we know there are many infinite number of infinities and everything else. But there are these paradox questions. The first paradox question of set theory is the following. The question is that is the set of all sets a part of the set of all sets? If the set of all sets is a part of the set of all sets, then it is not the set of all sets. If it is not a part of the set of all sets, then also the set of all sets does not contain it. So this question cannot be answered. Therefore, this infinity of infinities which you have cannot be modeled even if you have this infinite hierarchy of infinities. You cannot model everything. So that is the foundational problem of everything that we do. Our everything that we do has this fundamental problem. Therefore, philosophers, in order to understand what you call Brahman, has devised this unique artifact, and this artifact is enunciated in many ways. They say that the infinitely infinite at its pinnacle, which is beyond the set of all sets, collapses to the infinitesimal of infinitesimal, which is that everything which is larger than everything else is actually smaller than everything else. And it contains the property of both. This smaller than everything else contains the property of larger than everything else. And that is not in our set theory. And though we look at it as mumbo jumbo and everything else, but this logical artifact in our Vedantic philosophy is called Brahman and Atman. But it is a mathematical artifact that tries to go beyond set theory. So the question that you asked cannot be answered by current set theoretic or mathematical fundamentals, but it can be answered.
Okay, so regarding that, the creativity, I think one question was very interesting, and you said that it is possible to also, potentially it may be possible to have a Rabindranath Tagore or that kind of genius. But one thing we have to also consider that the human creativity also is a product of social interactions from society. Now, these AI models, still I think that is one part it is not addressed. I mean, how the social being, as a social being we produce, we think, we create, how it is getting modeled there.
I agree with you, because most of the errors that AI produces is because of its lack of social interaction information. And this social interaction information, we have reached the limit of amount of information that we can plug into AI. Therefore, there is something more which needs to be put into the model of AI for it to become more powerful with less compute power, like, दो apple, दो केला खाया, mess food खाया, फिर भी research कर रहा है. AI cannot do ना, AI will need megawatts of power to do the same research that you are doing. So, I agree that the amount of human to human information is not available in AI.
Okay, I think we can end it here. Over the tea can be further.
Thank you very much for your patience. Huh.
How do you see the future of classroom teaching? Because now students are using ChatGPT, teachers are using ChatGPT, everybody. So what is the future of classroom teaching?
So, classroom teaching will now become a combination of the following. People will teach whosoever wants to attend whatever they want to attend, and then people will have queries, people will have answers, instantly groups will form, they will interact to solve that problem with those answers. It is going to become a very dynamic, it is not going to be the synchronous classroom mechanism anymore. Degrees will go away. Degrees will go away, only competence will remain. Degrees.
So on behalf of Teachers Association,
Hey, amol chale sir. Thank you. পাস করেছি? পাস করেছি?
pass. pass. TGM লোক আবার pass.
বল আবার তুই বলিস না ফেল করেছিস?